Hi, I'm Rich with insideHPC, and we're here in Nolens at SC14 at the PGI booth, and I'm here with Michael Wolfe. Michael, how the hell are you?
Life is great. I'm having a fun time here and a fun time at work as well.
Okay, we're on the last day of SC14, but you know what I wanted to ask you first is, you guys are going forward with this message that HPC everywhere. Why is a compiler company talking about HPC everywhere?
Well, if you're going to run HPC anywhere, you need your compiler to provide the support.
Yeah.
And so one of the things we've had a customer talking to us about was they had an HPC code they were running on big clusters. I mean, like Titan-size clusters.
Yeah.
And they want to run that same code on an embedded system. This is a CUDA Fortran code in particular.
Okay.
And they want to run it in an on-site sensor. So what they're going to do is they asked us to support this particular code on an embedded system.
Yeah.
In this case, it was the NVIDIA Tegra TK1.
Okay.
That's a quad-core ARM.
Yeah. In fact, we have one right here, don't we? This
is
device.
awesome.
This is shipping, by the way, isn't it?
This is the TK1 dev kit.
Right.
So it comes with a quad-core ARM, a bunch of connections for video and power and whatnot.
Yeah.
And the ARM chip is under there.
Yeah.
With the Kepler GPU. It's a small Kepler, right? It's all low power.
Yeah.
But if you were here at the show and came at the appropriate time, we could show you the demo of the CUDA Fortran compiler, the compiler running on the board, compiling for itself, and the application running there as well.
Okay, so just for a little background, this device has, you know, a GPU integrated. It uses ARM as the main processor, right? That's yeah. Okay, but it boots Linux, right?
It does. Yeah.
And but you're saying that it's being used as the basis of an embedded device for a national lab.
Well, someone who's using large clusters.
Oh, someone. Okay, I apologize.
Yeah, it was one of our customers. I
Yes.
has to remain unnamed.
Okay.
But they're going to use this as in a sensor. It's a great opportunity for them and for us and for everybody that they can use the same applications. They will be able to use the same applications in a high performance, low power, low cost module.
So at least from the software you're providing, the rest of the world will be able to benefit from that, you're saying? Will be able to download it and do similar things?
All right, that's a fair question. And
yeah.
so there's a lot of work went into this demo.
Yeah.
So all we got working today is the CUDA Fortran compiler. We haven't done the entire stack.
Oh, okay, gotcha.
That will come.
Yeah.
We're not making announcements about when that will be available
Right.
because we have other work on the forefront that comes ahead of that.
Okay, fair enough. Well, let's talk about stuff that's real today, which was an announcement from PGI about power architecture, which today is at Power8, and they call it open power. You guys now have your tools available for that architecture?
So we've made the announcement that we are going to make the tools available.
Okay.
Not available yet, but we have a target and we have a plan and it's moving forward.
Yeah.
It will include Power8 host and host plus NVIDIA GPU. All the CUDA Fortran and OpenACC that we've got on x86 plus GPU will be available on Power plus GPU.
Okay, so not coincidentally, last week we had an announcement that the Coral systems, 2 of them, these 150 petaflop machines, will be based on open power and NVIDIA GPUs by chance. This sounds like a step towards making that a reality.
This was one of the keys actually towards that whole development because those customers, they wanted OpenACC, they wanted CUDA Fortran, they wanted full Fortran support, and I'm proud to say they wanted PGI as well.
Okay. Well, that's all goodness. We were talking earlier though, I wanted to shift gears and talk about an open source project that you're involved with that I think is very important to Exascale because it involves intellectual property. What was that exactly?
So this has to do with how we're implementing power. And we've had people ask us, how can you implement a whole new instruction set and do a whole new back end? So what we're doing is leveraging the power of the community, pun intended, by using the llvm infrastructure as our code generator back end.
Okay, so what is llvm? Help me out.
So it's an acronym for low-level virtual machine.
Yeah.
It's a compiler infrastructure first developed at Illinois some years ago.
Yeah.
And the lead developer for that is now working at Apple. Apple has adopted llvm for their code development. And a lot of other industry has as well. NVIDIA uses it for their CUDA backend. AMD uses it to generate code for their Radeon GPUs. Those are ones I know of, and there's other investments as well. And the point about intellectual property is the llvm license, it's open source,
Yeah.
but when you're developing code for it, you can protect your IP. Now this is important for industry because we have intellectual property that we want to keep ourselves, and we want to integrate things with our code, and with the llvm infrastructure, we're not tainting our intellectual property with open source license.
Okay, so like GPL, like Linux, if you contribute to that and you take advantage of it as a company, you are required, with that particular license, to publish it to everybody, right?
That is true.
And this is not the case here. You decide what you want to publish to the world.
And what that provides is, provides industry a better incentive to work with and contribute and develop that infrastructure, which is going to benefit everybody.
Yeah.
There's a lot of development, a lot of innovation has come out of compilers in industry relative to, say, I mean, there's a lot of good work in research,
right.
But if you look at a lot of the compiler infrastructure over the last 50 years, most of that innovation has come from industry.
I love where this is going, by the way, but I want to shift gears to, you guys got acquired by NVIDIA, what, 2 years ago?
Well, just a year and a bit ago.
Okay, so you live right down the road from me, off of Portland in a suburb there, right, Hillsboro. How has life changed inside of PGI? Because you guys were core to many things outside of GPU computing that a lot of the people in this room are integral, and I think they're curious. What's going on?
That's a fair question too. So PGI has been a big supplier and a big, for HPC since we were founded 25 years ago.
Yeah.
And NVIDIA realizes that we play an important role more than just for GPUs. Now the reason they bought us was because of our CUDA Fortran and OpenACC, because of the GPUs. But they realize that we play an important role. Customers depend on that. And that for us to be successful, for us that means the PGI compiler team and the PGI compilers, to be successful, we have to continue the wide support for all the hosts. That means full support for all x86 optimizations, full support now for all power optimizations, and eventually ARM as well.
Right.
And full support for other devices that are not NVIDIA devices. We still support the AMD APUs and GPUs. We're still going to support a wide range of devices. We have plans to support Knight's Landing.
Oh, wow.
That
Okay,
is
cool.
going to happen.
All right, well, they're down the street from you, actually, in Hillsboro, but long live the Portland group. Last question, Michael. How's life changed for you? You got a new office, I hear.
Yeah, this is really great. So the new office is just 4 miles from my house. So
Yeah.
4 days a week I ride my bike to work.
Really?
And on Thursdays I run.
Oh. Well, congratulations. That sounds ideal. Thanks for sharing this with us today.
It's been fun, Rich. Thanks for coming by.